In the last video, we defined an agent as anything that can perceive its environment and act upon it. One way that agents in ADK can act upon their environment is by using tools. For now, we're just going to consider tools to be Python functions that our agent has the ability to call. In this video, we're going to introduce a tool to an ADK project to demonstrate how useful they can be. First, let's make a new directory where we can build our project. Navigate into this directory and then open it in whichever IDE you prefer. For this video, we're going to use VS Code. The agent name in this video is Bitcoin_Bard. We need to make sure that we create a directory with the exact same name, or the ADK CLI will not know how to run this agent. After creating the directory, navigate into it. Once in the Bitcoin_Bard directory, we want to make an init.py file, a .m file, and an agent.py file. Just like in previous examples, in the init.py file, we want to say from this location import agent. Next, in the .m file, we want to set Google Gen AI use Vertex AI to be false, as this entire project is going to be run locally. And then we want to retrieve an API key from Google's AI Studio. We retrieve the API key by going to aistudio.google.com and selecting Get API Key in the bottom left-hand corner. Once there, we click Create API Key in the top right, and then we select an existing GCP project or create a new one that this API key can be charged to, and then create an API key belonging to that project. Once you have the API key, copy and paste it into your .m file, setting the Google API key variable equal to your API key. Now that init.py file and the .m file are taken care of, we can start developing our agent. Just as in other examples, we're going to import the agent class from google.adk.agents. And just like in the previous example, we're going to set this to the root agent variable. Matching the name of our directory, we're going to call the agent Bitcoin_Bard. And the purpose of this agent is it is going to be a theatrical bard who delivers Bitcoin prices in rhymes and soliloquies. Make sure you add a comma after each argument. And just like in previous videos, our instruction is going to be a multi-line string that's going to describe the expected behavior of our agent. You're William Shakespeare reincarnated as a playwright who has discovered the wonders of modern finance. Do not break character. Always respond in grandiose Elizabethan style, whether discussing markets, money, or mundane matters. Before we can run ADK Web, we need to install the Google ADK Python package. So first, let's back out to the root directory, use venv to create a virtual environment, activate our virtual environment, and then pip install Google ADK. Now, whilst making sure we're in the root directory, run ADK Web so that we can interact with our agent. Just like in previous videos, the available agents in our project are surfaced on the left-hand side, and in this project we only have access to the Bitcoin_Bard. Let's start by typing a simple message, hello, and we get an error that no model has been found for the Bitcoin_Bard. This error is referring to the model parameter which we should have passed when creating the agent. We're going to set the model to Gemini 2.0 Flash. Now that we've added a model, stop the server from running in the command line, and then rerun ADK Web and access the server again in the browser. Let's start again by typing a simple hello message to the Bitcoin_Bard. Hark, what light through yonder keyboard breaks? 'Tis I. So, as you can see, this is following our system instructions, which have said, you are William Shakespeare reincarnated as a playwright who has discovered the wonders of modern finance. So let's see what it knows about modern finance. What can you tell me about modern finance? Hark, a question of modern finance doth pique my interest. So as you can see here, it's sticking to character and it is giving us an in-depth description of different features of modern finance. However, the key feature that we wanted was the ability to deliver Bitcoin prices. So let's test that out. What is the current price of Bitcoin in US dollars? Hark, a question of the coin most cryptic. Attend and thou shalt know the state of Bitcoin's fleeting worth in these United Statesian dollars. Though bear in mind, like a fickle sprite, its value doth oft shift and shimmer. So it says here that my sources whisper that Bitcoin doth currently trade near 69,000 US dollars. So I'm going to check first, but I don't think that price is correct. So a quick Google shows me that the current price of Bitcoin is actually $116,000 rather than the $69,000 quoted by the Bitcoin_Bard. This will be because the price of Bitcoin will have been closer to $69,000 when the Gemini 2.0 Flash model was trained. So we need a way for our agent to access current prices. To do this, we're going to add a tool that can fetch the current price of Bitcoin and make that available to our agent. So stop the server running, and in the Bitcoin Bard directory, create a tools.py file. We're going to use an API to retrieve the current price of Bitcoin, and therefore we need to import the requests library. Next, we're going to define a function, get current Bitcoin price, and we're going to start by setting the URL equal to the following CoinGecko Bitcoin price API endpoint. So this is api.coingecko.com/API/v3/simple/price with the following parameters passed, where IDs is equal to Bitcoin and VS currencies is equal to USD. And we can test this in a browser. If we go to this endpoint, we can see the current price of Bitcoin, $116,000, is returned in a JSON string like so. Next, we're going to call the API. So I'm going to create a try except pair. Inside my try, I'm going to set the response equal to requests.get URL, and I'm going to set the timeout to 10 seconds. If it takes longer than 10 seconds, then we're going to stop trying. I'm going to add a response.raise for status, and what this does is this raises an error when the response status is anything but 200. Next, I'm going to pass the response as a JSON and set that to a variable called data. And then I'm going to open another try except, as the expected keys may not actually be present in the return data. To understand where the Bitcoin price might be found, I can go back to the endpoint in our browser. And if you look at the expected response, I need to go to the value of the Bitcoin key. And then within that value, I need to go to the value of the USD key. So to access this, we go to data, Bitcoin, USD. And this should return the current USD value of Bitcoin as an integer. Now, since this function is going to be used as a tool in ADK, rather than just returning the Bitcoin price, we want to return a descriptive JSON. So this is going to be represented by a Python dictionary with a descriptive key, current Bitcoin price, and the corresponding value being the current price of Bitcoin. The errors we would expect here would be a key error or a type error. We're going to assign them to the variable E, and in the event that happens, we're still going to return this descriptive JSON. However, the value is going to be a string explaining what has happened. And in the event that the requests.get fails, we can accept a request exception as E, and again we return a JSON with the same descriptive key. However, this time the value is explaining a different type of error. All of these responses are descriptive enough to be handled correctly by our agent. Now that we've finished defining our function, we need to add some additional information for this to be used by our agent. First, we set the expected response type to be a dictionary, because in all three scenarios we do return a Python dictionary, whether that returns the actual Bitcoin price or one of the two errors. And then we also need to add a docstring explaining the purpose of this function and its expected behavior. To do this, we define a multi-line string explaining in simple terms what this function does. It fetches the current Bitcoin price in USD using the CoinGecko API. The function makes a GET request to CoinGecko's simple price endpoint. If the request is successful and the response is valid JSON, the current Bitcoin price in USD is extracted and returned. This function returns a dictionary with a single key, current Bitcoin price. On success, this is the Bitcoin price as an integer. In the event of a JSON parse error, this is an error message string. And in the event of a request failure, this is also an error message string. Now that we have our get current Bitcoin price tool, we need to make this available to our agent. To do this, we go back to our agent.py file where the Bitcoin Bard agent is defined. We add an additional parameter to the agent initialization called tools, and we set this to an array of the tools that we want our agent to have access to. Then, from our tools.py file, we import the get current Bitcoin price tool, and then we copy this function name and paste it into our tools array. It's also helpful if we explain to our agent how this tool can be used in our system instructions. So let's add some instructions on what to do when asked about the current price of Bitcoin. When the user asks about Bitcoin or its price, you must consult your Oracle, the tool, to fetch the latest market truth priced in United States dollars, then weave it into a theatrical announcement as though it were the fate of kingdoms. And then more formally, we can say you have access to the following tools: get current Bitcoin price. And then just as before, we run ADK web, so that we can interact with our agent. Now it has access to a tool. Let's start with a simple hello to check expected behavior. And as you can see, this is still responding in the style of Shakespeare as expected. So now let's ask it about the current price of Bitcoin. And as you can see, we've got this get current Bitcoin price tool selection and call here. So let's check the answer. Bitcoin, that digital marvel, doth currently stand at a princely sum of 116,055 United States dollars, which is a much more up-to-date answer than $69,000, which it was saying previously. To see an illustration of what's just happened, we can click the Events tab on the left-hand side and click into the first event. You can see that our agent produced this first response when we said hello, and then if we click through the events, we can see what happens next. The Get Current Bitcoin Price tool is called, then the arrow changes direction and the response is returned to our agent, and then finally our agent produces the text response here that contains the latest Bitcoin price. So that's how we add tool use to our ADK agents. Thank you for watching, and please like and subscribe if you enjoyed the video.